Okay, so we're going to do a little bit of converting recurring decimals into fractions. I'm going to start with a really nice simple example. That's 0.6 recurring. I think we probably all know what 0.6 recurring is, so let's give it a go. Our first step is we're going to give our recurring decimal a name. So we'll pick a letter. We're going to call it A. Nothing too creative. So A equals 0.6 recurring. And there's a little trick that helps us to be able to convert that into a fraction. We're going to call A 0.6 recurring, and we're going to find out what 10A is. So 10A is 10 times A. 10 times 0.6 recurring is 6.6 recurring. The 6 in the tenths column becomes 6 units. The 6 in the hundredths column becomes tenths, and so on and so on and so on ad infinitum. So we've got 6.6 recurring, we've got 0.6 recurring. Now what we're going to do is we're going to do 10A take away A. We're going to have our 10A take away A. So that is 6.6 recurring take away 0.6 recurring. Set that out properly as a column subtraction. These are both 0.6 recurring, so they go on and on and on and on, and we're always taking 6 from 6. So we've got 6 take away 6 there, and there, and there, and there, and all the way. So that makes 0. Decimal point, 6 take away nothing is 6. So 10A take away A is 6. Okay, we know that 10A take away A is 9A. So 9A equals 6. All we need to do now is find out what A is. So doing the same thing to both sides of the equation, to find out what A is we need to divide 9A by 9. So we divide by 9 on either side. A equals 6 divided by 9. We can simplify that fraction. A equals 2 divided by 3, or 2/3. And we knew it was 2/3 to start with, but that's our process. Okay, we'll try something a little bit more complicated. We have got 0.27 recurring. So if we were to write that number out in full, it would be 0.272727, and so on. Now we can't multiply that by 10. We can, but it won't help us, because that would give us 2.72 recurring, and that's not easy to do that bit of subtraction on. So we need to be a little bit cleverer. Because there are 2 recurring digits, instead of multiplying it by 10, we're going to multiply it by 100. So again, we'll use A. A equals 0.27 recurring, and now we're going to find 100A. 0.2 times 100 is not 2 but 20. 0.07 times 100 is not 0.7, it's going to be 7. So we end up with 27.27 recurring. And now we can do the same thing again. So 100A take away A is 27.27 recurring. We're taking away the A, and the A was 0.27 recurring. As in the previous case, these recurring decimals subtract from each other, leaving nothing. 7 take 7 is nothing, 2 take 2 is nothing, and that's true all the way along. So we have 0, 0, decimal point. 7 take nothing is 7. There's nothing to take away from the 2 there, so it's 27. So 100A minus A is 99A. 99A equals 27. To find out what 1A is, we need to divide by 99, so we need to divide by 99 on the other side as well. A is 27 over 99, and we just need to simplify that now. Common factors of 27 and 99. They're both in the 9 times table. 3 9s is 27. 11 9s is 99. So that simplifies to 3 over 11. So it's just a key point to remember. For the number of recurring digits, so if there's one recurring digit, we times by 10, as in this example here, to find 10a and then subtract the a. If there are 2 recurring digits, we multiply by 100, as in this example here. 3 recurring digits multiplied by 1000, and so on. But that little bit of algebra there, that helps us to get our answer. We've got that written as a fraction.